Imagine a cosmic event so powerful that it forges that very elements that make up our world. Welcome to the enigmatic world of kilonovas, where neutron stars collide and the universe puts on a breathtaking display. At the heart of a kilonova lies a catastrophic collision. Picture two neutron stars or a neutron star and a black hole, dancing through the cosmos until their gravitational embrace becomes inevitable. The resulting cosmic ballet unleashes a torrent of material, a dazzling explosion we call a kilonova. As the collision unfolds, a deluge of material rich in neutrons is ejected. This violent celestial forge gives birth to the heavyweights of the periodic table: gold, platinum, uranium, and even the iodine coursing through our veins. Kilonovas, in essence, are cosmic alchemists shaping the elements that adorn our world. Why should we care about these celestial fireworks? Kilonovas hold the secrets to half of the periodic table, including elements crucial for our daily lives, from the neodymium in our phones to the molybdenum sustaining plant life. Kilonovas unveil the cosmic origins of these elements. But how do scientists study these fleeting events? Armed with gravitational wave detectors, researchers embark on a quest to catch the aftermath of neutron star mergers. It's a challenging pursuit. Kilonovas are faint and fleeting, yet each observation unveils the mysteries of nuclear physics, astrophysical conditions, and the fundamental interactions shaping our universe. Kilonovas are not just dazzling displays, they are cosmic storytellers. By decoding their radiance, scientists piece together the puzzle of the universe's expansion, the behavior of fundamental particles, and the birth of elements under extreme conditions. However, the journey is not without its mysteries. The spherical nature of observed kilonovas challenges existing models. We are still pondering the nuclear and particle physics required for the alchemical creation of elements in these cosmic collisions. Now, let's clarify the cosmic hierarchy. Novas, like faint whispers, are overshadowed by the brilliance of supernovas. Kilonovas, though not as powerful as supernovas, outshine novas by 1,000-fold. Each a unique spectacle shaped by the dramatic events unfolding in the cosmos. So, how do neutron stars weave gold into the cosmic fabric? It's a tale of free neutrons, a process known as rapid neutron capture or the R process. In the aftermath of a kilonova, iron absorbs these free neutrons, transforming into elements heavier than itself: gold, silver, platinum, a cosmic dance of creation. As we gaze into the universe, kilonovas stand as celestial crucibles shaping the elements that weave the tapestry of our existence. These cosmic collisions, brief yet powerful, continue to unveil the profound mysteries of our cosmic origins.